Hello, everyone. Today we will be talking a bit about the difference of squares. This is something that's very common and you see it everywhere, and we know how to implement it, but rarely do people actually implement this idea using concrete numbers. Usually we think of it as an abstract idea, but it can be used all over the place. So if we look at this first question, we have 21 squared minus 19 squared is what? Now you could go about this by squaring 21 and then subtracting whatever 19 squared is, and you will find your answer. But there's a much simpler way, and all we have to do is apply some of the algebra that we've learned in our earlier classes, and it will go much more smooth. If I scroll over here, we know that x squared minus y squared equals x plus y times x minus y. This was something we learned in algebra because if you distribute x to the x, you get x squared, and x to minus y, you get minus xy. Y to x is plus xy, and so those two cancel out, and you have y and minus y. So you're left with x squared minus xy plus xy minus y squared. And ultimately, these two will cancel out, and you're just left with x plus y times x minus y equals x squared minus y squared. And it removes these middle steps. And so it's actually a simpler way of doing it. So if we apply this back to 21 squared minus 19 squared, all we have to do is think of 21 as our x and 19 as our y. And then we can just apply this formula right here, the x squared minus y squared equals x plus y times x minus y, and we'll find our answer. I encourage you to pause the video and to see if you can figure out what the answer is to this one. It's very simple, and I'm sure you'll be surprised by how quick you can get to it rather than having to square each of them and subtract. All right, so down here, I did this one myself. So if x is 21 and y is 19, we have 21 plus 19, which is 40, and then 21 minus 19, which is 2. When we multiply those two, it's 80. It's that simple. If we'd gone about it by squaring them each and subtracting them, you get these big numbers and then you have to subtract them. It's not awful, but doing it this way saves so much time, and you can figure out the answer without even having to write something down or use a calculator. One application of this is in right triangles. If you remember the formula for a right triangle, if we have two of the sides, it's a squared plus b squared equals c squared, where c squared is the hypotenuse. In this question, I created a triangle with a hypotenuse of 41 and a leg of 9. We could, of course, do 41 squared minus 9 squared and take the square root. We could do that by hand, or we can use the method we just learned to simplify this problem and make it a lot easier. So if we turn 41 squared, have 41 be our x and 9 be our y, we can simplify this problem. So over here, we know that the side length that we're trying to find over here is equal to the square root of the hypotenuse, which is 41, minus the square of the leg, which is 9. And so we have the unknown side length is equal to the square root of 41 squared minus 9 squared. And using the trick we learned, x squared minus y squared equals x plus y times x minus y. So we can do 41 squared minus 9 squared equals 41 plus 9 times 41 minus 9. And so 41 plus 9 is our 50 down here, and 41 minus 9 is a 32 down here. So we know our answer's got to be the square root of 50 times 32. And whenever you see a square root, rather than trying to multiply these numbers and make it bigger to see what it is, typically we want to factor it out. That way we can see what factors we can pull out and what our answer is going to be. In this case, I made it a nice number so that we can pull out all of the numbers and have it be whole at the end. And so if we factor 50, we have 2 times 5 times 5. So I wrote that as 2 times 5 squared. And then factoring 32, we have 2 to the 5th, but I wrote that as 2 times 4 squared. So here we can pull out the 4 squared from the square root, and it'll just be 4. We can pull out the 5 squared, and it'll be 5. We have two 2's that can leave the square root together. Right here is the 2. Multiplying all of these together, 2 times 5 times 4, we get our answer of 40. And that will be our leg of this triangle right here. And this works for any problem you were to do. It won't always be a nice number. Sometimes it'll be a square root, but using this step right here, where we do x squared minus y squared into x plus y times x minus y, we can find the answer a lot quicker. And so thank you for watching my video on the difference of squares. I hope that was helpful and it can speed up some processes in your math class, especially using right triangles, which are used so often. Good luck to you. Thank you for watching.